Good morning, friends. Today I am covering chi-square test. Let's start. A chi-square test is a statistical method used to determine if there is a significant difference between expected frequencies and observed frequencies in one or more categories. Essentially, it helps us to figure out if a relationship or a pattern we see in categorical data is a real phenomena or just a result of random chance. There are two main types of chi-square test. While the core math is identical, the test is applied in two different scenarios. First is goodness of fit test. Purposes determines if a sample data fits theoretical distribution. Example, you roll a die 60 times. Do you get each number roughly 10 times or is the die rigged? Die is basically when which you use in a Ludo game. Okay. Numbers written are 1, 2, 3, 4, 5, 6. So do you get each number? Let's say 1 roughly 10 times. It's a probability based on probability or is the die rigged? If you are not getting a number roughly 10 times, there is a chance a die is rigged. Another one is test of independence. Purpose determines if two categorical value variables are independent of each other, that is, whether they are associated. Example, does a person's city of residence, Pune or Mumbai, influence their preferred choice of beverage, tea versus coffee? The core formula, the test relies on calculating a chi-square statistic using the fo- following formula. Formula is equal to summation of observed minus expected value ka whole square divided by expected value. Okay, where O is observed value, the actual data collected, E is expected value, the data we expect to see if the null hypothesis is true. So this sign represents basically summation added up the calculation for all categories. So let's come to a real life example. Customer preference in a cafe. Let's say you own a cafe with two branches in Pune, Kharadi and Vimannagar. You want to know if location influences a customer's drink preference or if people order similarly regardless of the branch. So this is our purpose. Whether a customer drink preference is affected by the location or not. Step 1. Formulate the hypothesis. First is null hypothesis H naught. Location and beverage preferences are independent. Location does not affect choice. Alternative hypothesis H1. Location and beverage preferences are dependent. That is, location does affect choice. Step 2. Gather the observed data. You survey 300 customers across both locations and record their preferences. Both locations here are Kharadi and Vimannagar. So location here are Kharadi and Vimannagar, and the beverages are tea, coffee, and cold beverage, and this is the total value. So in Kharadi, 60 people are preferring tea, 40 people are preferring coffee, and 50 people are preferring cold beverage. So sum is equal to 150. In Vimannagar, the number is 80, 30, 40, and the sum is equal to 150. So this is the row total 150, 150, and this is the column total 140, 70, and 90, and this is combined 300. Now come to step 3. So in step 1 we just formulate the hypothesis, and in step 2 we gather the observed data. In step 3 calculate expected frequencies. If location did not matter, H naught is true, which is our null hypothesis. The distribution of drinks should be proportionally identical in both places. The formula for the expected value of any cell in a matrix is E is equal to row total into column total divided by grand total. Basically, row total is 150 and for Kharadi and Kharadi T, and for Viman Nagar it is 140. So let's calculate E for each cell. Let's say for Kharadi and tea. Kharadi and tea, this combination. The row total is 150. The column total is 140 divided by grand total, which is 300. 150 into 140 divided by 300 is equal to 70. Let's come to Kharadi and coffee. Kharadi and coffee is 150 row total, column total is 70 divided by 300. 150 into 70 divided by 300. It's a division sign. And for Kharadi and cold beverage, the row total remains same as 150, column total changes to 90. So 150 into 90 divided by 300 equal to 45. Because the row totals for Viman Nagar are also 150, its expected value will be exactly the same 70, 35, and 45. If I go for Viman Nagar and T, then again the row total is 150 and column total is 140. If I go for Viman Nagar and coffee, again the row total is 150, column total is 70. If I go for Viman Nagar and cold beverage, again the row total is 150 and column total is 90. So this is written here because the row totals for Viman Nagar are also 150. Its expected value will be exactly the same 70, 35, and 45, which are in case of Kharadi. Step 4, complete the chi-square statistic. Now we plug our observed and expected values into the formula. Observed minus expected value का whole square divided by expected value for all 6 cells and then sum up. So for Kharadi T, observed is 60 and expected is 70. This is observed minus expected is 10. 60 minus 7 is sorry minus 10. Observed minus expected ka whole square is equal to 100. Observed minus expected whole square divided by expected. 100 divided by 70. For Kharadi and coffee, what is the observed value? For Kharadi and coffee, observed value is 40. Expected value is 35. 40 and 35. Overall, uh, observed minus expected is equal to 5. 5 square is 25. Then 25 divided by 35 is equal to 0.714. So we can do for Kharadi and cold beverage. This is cold beverage, okay? The same category, cold beverage. So don't confuse why it is written as cold, it is cold beverage. And similarly, we can do for Viman Nagar tea, Viman Nagar coffee, and Viman Nagar cold beverage. So don't confuse with this. This is cold beverage, cold beverage. And the same is written here. Beverage is not written here, but it is cold beverage. Okay. So similarly, we can find the value for Viman Nagar T, observed minus expected ka whole square, then observed minus expected ka whole square divided by expected. So these are the values we get. 1.428, 0.714, 0.556, 1.428, 0.714, 0.556. So sum the values chi square is equal to 5.396. So our calculated chi-square value is 5.40. You can sum up this and it is 5.40. Now come to the fourth step, interpreting the result. To know if 5.40 is significant, we need two more things. First is degree of freedom df. For a test of independence, df is equal to rows minus 1 into column minus 1. We have two rows, Kharadi and Viman Nagar. These are the two rows. And we have three column tea, coffee, and cold beverage. So df equal to 2 minus 1 into 3 minus 1 equal to 1 into 2, which is 2. So let's come to the next step, alpha level. The standard threshold for significance is 0.05, that is, a 5% risk of concluding a difference exists when it does not. Final verdict via chi-square distribution table. If you look at a standard statistical chi-square table for df is equal to 2 and alpha is equal to 0.05, the critical value is 5.99. I have not shared any screenshot here, but it is quite easily available. If you check the chi-square table for degree of freedom is equal to 2 and alpha is equal to 0.05, the critical value is 5.99. The decision rule: if calculated chi-square value is greater than critical value, reject null hypothesis. Significant difference: if calculated chi-square value is less than equal to critical value, fail to reject null hypothesis, that is, no significant difference. Because our calculated value 5.40 is less than 5.99, we fail to reject the null hypothesis. What this means in short, the slight difference in drink orders between Kharadi and Vimannagar in our sample are not strong enough to prove that location dictates taste. For now, we can assume consumer preferences across both Pune locations are fundamentally the same and any variance is just random noise. So I hope you understand what is chi-square test, what are the different steps to find the values and how we can accept or reject a null hypothesis. So I hope you learned something new today. If you are not subscribed to my channel, please subscribe to my channel for more upcoming videos. Thank you.